Yeah, you say that now until you're stressing out later on when we're taking the test, and then you're like, crud. Crud! Okay, let's do it.
We got it. Kill it.
Go! This one is slightly new. Slightly new, folks. In that they're giving us a geometric shape on one side, and then they're giving us a function on the other. So, one way we're going to integrate is by finding the areas, and one way we're going to integrate is by finding antiderivatives. Now, I don't even know what the questions say anymore because I don't remember this question. We're just going to dive right in. I hope I don't mess it up. Okay. But, does it make sense that this is f prime? They've been saying this with the other ones too, right? Like g is the integral of f, then they graph f, that's really g prime. Okay? But anyway, this is the derivative. Great. They told us the intercepts are at -2, that's right here, and 3 ln 5/3, which seems complicated, but all they did was take this piece here and solve it for 0. They added 3, they divided by 5, they took the natural log, then they multiplied by -3. Okay? That's why that's what that is. Oh, and the negative, it should be 3/5. The negative out front, flip the fraction inside is what they did. But either way. And we know that f of 0 is 5. The fact that they gave us this piece means we can find any other values of f. Okay? So, find all values for where f has a point of inflection. Well, here's our rule. We need f double prime to change sign. Okay? So, because I have a graph of f prime, I know that starting out here, what's f double prime on this interval? Negative, and then it's positive. I'm just going to go ahead and make a little number line for f double prime. We have -2, and we have 3 ln 5/3. Cool. And we also have 0 is going to matter. We don't need 3 ln 5/3. I'm sorry. We just need -2 and 0. F double prime before -2 is negative because the slope is negative there. The slope of f prime. Between -2 and 0, the slope of f prime is positive. And after 0, negative. So f has points of inflection when x is -2 and when x is 0. But remember, to get full points, you got to explain how f double prime changes sign. Not just that it changes sign, but how it does it. So let's type this out here, because it'll be a lot easier for me, and that's what matters. We're going to write for a right here. Come on. A. F of x has, what's wrong, Liam? Did I mess up?
It's like greater than 0, it's concave up.
Greater than 0. Oh, it is concave, but that's the graph of f prime.
Okay.
We don't care about that. Cool, we care about whether it's increasing or decreasing because that tells us the slope of f double prime. Okay? So, f of x has points of inflection. Let me make sure I'm answering this right. All values of x, okay, at x equals -2. And let's just write it right after that. Because f double prime of x changes from negative to positive. And at x equals 0, because f double prime changes from positive, negative. What's up? So, f double prime will be undefined. That's true. But that doesn't matter. To be a point of inflection, we need the second derivative to change sign, and we need the original function, in this case f, to be defined. And because the derivative of f is defined everywhere, f is defined everywhere. Does that make sense?
But it's not differentiable.
So hold on. F is differentiable at 0.
But f double prime is not.
F prime is not differentiable at 0, which means f double prime doesn't exist at 0. But that doesn't matter. Yes. Okay? Does everyone understand that? It doesn't matter if the second derivative is undefined. The original f has to be defined, and it is, because the derivative exists. If the derivative exists, f has to be defined and continuous. Okay? Okay. B says find f at -4. Well, we know f of 0 is 5, so I know that f of x is 5 plus the integral from 0 to x of f prime of t dt. Can we handle that? That's our rule. Okay? We want f of -4. That's 5 plus the integral from 0 to -4 f prime of dtt. But I told you never, ever, ever, just with areas on a number line like this, okay? Never integrate left. Never integrate from 0 to -4. If you're doing it on a calculator, if you're doing it by hand, like actual calculus, don't worry about it. Do it by hand, it's fine. But if you're doing areas, switch it. So we're going to rewrite that as 5 minus the integral from -4 to 0. So Now we got to integrate f prime from -4 to 0. Well, all that means is, let's come back up here. We're just going to do area, right? And we said when you got these weird semicircles that are off the graph like that, you make a rectangle. What's the area of that rectangle? 8. And we subtract off the area of the semicircle, which has a radius of 2. So the whole thing will be 4 pi, but half of it will be 2 pi. So it's 8 minus 2 pi is the area then. Can we handle that? So it's 5 minus the quantity, 8 minus 2 pi. And in free response, you can leave it like that, gang. You don't have to simplify anything. You can't have like operations like integrals and stuff. But if it's just arithmetic, you can leave it just like that. But let's just do it. It's really 2 pi minus 3. Is okay? To find f of 4, I'm going to come all the way back over here. I'm going a little quick. That's 5 plus the integral from 0 to 4 of f prime. But rather than just write f prime, I know from 0 to 4, f prime is that dumb thing. So I'm gonna put that in there, okay? If this function here didn't start until like 2, I'd have to integrate from 0 to 2 and then 2 to 4. I'd have to do 2 separate integrals. Okay? All right. So we're going to talk right over the announcements. This is going to be not a good video. 5e to the negative x over 3, right? Minus 3.
Also an update to our favorite rescue dog that was rescued earlier on.
Yay for the rescue dog.
The last information I had is that she...
The integral of this, can you guys do this in your head? It's, you got to have the e, but then you got to multiply by -3. So it's actually negative 15 minus 3x from 0 to 4. That's just like a u sub right there, by the way, guys. Let u be negative x over 3, du is negative 1/3, and you can work it out, okay? But it's 5 plus, if you plug in 4, you get negative 15 e to the negative 4/3 minus 12. Minus, if you plug in 0, you get negative 15 times 1 minus 0. How's that going? Oh, good for Leo. Okay? So that's 5 plus... Oh, we got to put all this together here? I was a pain in the butt. That's negative 15 e to the negative 4/3, right? You might see me messing this up here. I don't want to mess it up. It's 20 minus 12 is 8.
8, yep.
It's f of 4. Okay? I know it looks nasty, but you don't have to work that out. That's just what it is. This is a non-calculator question. And then C says find the absolute max. Well, that means we need to find the value of f, right? Max, f is max of f, right? At negative 4, which we already found. At positive 4, which we already found. And also at right there. Okay, so we haven't found that yet. Huh? No, we know that x value, but we don't know what f is at that x value. Okay? So we have to find f of 3 ln of 5/3. So, but remember I told you this. For C, you always write, I need to know where f prime is 0. That was at negative 2. And I forget already what it was. I know it was ln of 5/3. 3 ln 5/3. Cool. That's step 1 for this. Step 2 is find all the values we need to know. We need f of negative 4. We need f of 4. And we don't need f of negative 2, but we do need f because we're looking for an absolute max, right? And negative 2, the derivative doesn't change sign there, so it can't be a max. Okay? And we're going to write a little sentence that says, I checked where f prime changed from positive to negative. Cool? So we already know these. I'll forget what they are already. 2 pi minus 3. This was negative 15 e to negative 4/3. Now, I know you don't know what that is, but do we know definitely that that's going to be less than f right here? Why do I know f of 4 has to be less than f of 3 ln 5/3? What's f doing on this interval? Decreases, right? So the max is going to be at 3 ln 5/3. Okay? We just got to do it. So it's... I forget what it was already, my whole definition of it. What was the y value we knew? 5? 5 plus the integral from 0 to to 3 ln 5/3 of e to the negative x over 3 minus 3. Is that what it was? Was there a 5 here?
Yeah.
Is that good? And look, we already did that derivative, so there's really no reason to write it out again, but I am. It was negative 15 e to the negative x over 3 minus 3x from 0 to 3 ln 5/3. And you got to plug it in, which I know you don't like, but it's not that bad. Check this out. If I plug in 3 ln 5, first off, if I plug 3 ln 5/3 in here, does it make sense that 3's are going to cancel? And the negative out front, I can make the exponent, so it's really going to be e to the ln of 3/5, which is just 3/5, right? Okay, so we'll work on that. Minus 9 ln 5/3 minus, if you plug in 0, you get negative 15 minus 0. Yeah. So that's 20 plus negative 15 times 3/5. This is negative 9. Yeah, this is negative 9. Minus 9 ln 5/3, which is really 11 minus 9 ln 5/3. And then you're going to write your little sentence, okay? What's up, Sharon? I'm sorry, what? No. And actually, you're very correct. I'm doing way too much work here. Yeah, like, you don't have to do all that stuff. No, that's way too much. You're right. This will be fine, but you could have said absolutely 3 ln 5/3. But you got to explain that f prime is positive from negative 4 to 3 ln 5/3, and then negative after, which would have been a whole lot more easier for me to do. Thank you, Sharon.
Mr. Smith,
Yeah.
on the bullet points, she gave me -2 for these two, but I'm thinking